Well, students, in this part of the unit, you will learn about another important topic, that is solenoid. You have studied that magnetic field is produced in a conductor when electric current passes through it. You also studied the magnetic field due to a current carrying circular loop. So, solenoid is a device which produces magnetic field, that is also uniform magnetic fields, inside it. Up to a greater length of the solenoid, we get uniform and strong magnetic field. That device is called solenoid. How it is formed? Solenoid is a cylindrical shaped structure. It is made up of closely wound circular loops of insulated conducting wire. Insulated conducting wires, if these are wound closely in the form of a helical spring or a cylinder, that structure is called solenoid. Let us draw its diagram. So the direction of flow of current is like this. If we take one such loop of this solenoid, we can understand it in a better way. This is one such loop of a solenoid. A number of turns are closely wound. This material is conducting wire. This is a conducting wire and insulated one. So direction of flow of current is clockwise through it. So through one such turn, what is the magnetic field? Because of one loop, this is the direction of magnetic field. Now two such loops we will take. One loop is this and the direction of flow of current is clockwise. So from this side, magnetic field lines are entering and coming out in the form of circular loops like this. Magnetic field lines are there and one such turn we will take here. ये दूसरा टर्न है. एक टर्न यहाँ पर आपने लिया, इसमें करंट ऐसे फ्लो हो रहा है, मैग्नेटिक फील्ड लाइंस ऐसे हैं, सेंटर पर along the axis of this turn of this loop magnetic field is there और बाहर को इस तरह से आ रहा है. और यहाँ पर जो लूप है उसमें भी करंट की डायरेक्शन क्लॉकवाइज है. तो उसमें जो करंट की वजह से जो मैग्नेटिक फील्ड है वो बाहर से अंदर की ओर आ रहा है. आपने यहाँ पर देखा था, यहाँ पर मैग्नेटिक फील्ड बाहर को आ रहा है और यहाँ पर यहाँ से अंदर को आ रहा है. तो ये मैग्नेटिक फील्ड, दिस मैग्नेटिक फील्ड will cancel out this magnetic field. This magnetic field which is entering into this turn will cancel out this magnetic field because of this turn which is leaving this turn. So outside this coil, outside this solenoid, the magnetic field will be very weak. But as far as the center of this solenoid is concerned, magnetic field due to one turn will be added up with the magnetic field due to second turn and with all the turns. So there will be a strong magnetic field produced inside the solenoid, whereas outside the solenoid magnetic field will be almost negligible or very weak magnetic field. Once again try to understand it. ये दो टर्न हम ले रहे हैं, इसमें बहुत सारे टर्न हैं, इसमें कोई दो टर्न हम लेंगे. सपोज ये आप टर्न ले लीजिए, इसमें डायरेक्शन ऑफ करंट क्या है? क्लॉकवाइज. यहाँ पर करंट की डायरेक्शन नीचे को है तो मैग्नेटिक फील्ड लाइन से ऐसे जाएंगी, इस तरह से इनकी डायरेक्शन होगी. यहाँ से बाहर आ रहा है मैग्नेटिक फील्ड, यहाँ से अंदर को जा रहा है और मैग्नेटिक फील्ड सेंटर पर अलोंग द एक्सिस ऑफ दिस लूप इज देयर. मैग्नेटिक फील्ड सेंटर पर और जो बाहर आ रहा है तो बाहर को आ रहा है. इसके अलावा और भी तो बहुत सारे टर्न है. दूसरा टर्न ले लीजिए एडजेसेंट टू दिस, इसमें मैग्नेटिक फील्ड भी ऐसे ही आएगा क्योंकि करंट की डायरेक्शन सेम है. तो ये जो मैग्नेटिक फील्ड यहाँ एंटर कर रहा है, यहाँ से जो मैग्नेटिक फील्ड इसको लीव कर रहा था वो तो उसको कैंसिल आउट करेगा, कैंसिल करेगा तो बाहर मैग्नेटिक फील्ड नहीं होगा. लेकिन जो ये कंपोनेंट मैग्नेटिक फील्ड का है और इसका कंपोनेंट मैग्नेटिक फील्ड का अलोंग द एक्सिस, बोथ विल बी एडेड. So likely all the loops will be contributing in magnetic field along its axis. तो इसको अगर आप दिखाना चाहें मैग्नेटिक फील्ड को, कैसे दिखाएंगे? So magnetic field due to this solenoid will be shown by these magnetic field lines. अब इनकी डायरेक्शन क्या होगी? कौन सा एंड इस सोलेनोइड का नॉर्थ एंड होगा और कौन सा एंड साउथ एंड होगा. इट एक्ट्स एज अ बार मैग्नेट ऑल्सो. तो बार मैग्नेट के दो पोल होते हैं, नॉर्थ पोल और साउथ पोल. तो इसका कौन सा एंड नॉर्थ पोल होगा. अब इसमें देखिए आप, इसमें क्लॉकवाइज करंट की डायरेक्शन है. क्लॉकवाइज अगर करंट की डायरेक्शन है तो जिस तरफ क्लॉकवाइज डायरेक्शन है वो साउथ पोल होता है. वो क्या होता है, साउथ पोल. जैसे ये क्लॉकवाइज करंट की डायरेक्शन अगर है लाइक दिस, इफ करंट इज फ्लोइंग लाइक दिस, तो दिस इज रिजेंबलिंग विद एस लेटर ऑफ इंग्लिश. एस करंट ऐसे जा रही है तो ये साउथ पोल हो जाएगा. लेट अस सी द डायरेक्शन और पोलैरिटी ऑफ द सोलेनॉइड एट अदर एंड. ये जो टर्न है लास्ट वाला, इसमें करंट की डायरेक्शन इस तरफ से क्या है, क्लॉकवाइज. तो इस तरफ से क्या होगी, एंटी क्लॉकवाइज. एंटी क्लॉकवाइज मीन्स इट विल रिजेंबल विद द लेटर एन. ये एंटी क्लॉकवाइज करंट की डायरेक्शन है तो ये नॉर्थ पोल होगा और ये साउथ पोल होगा. मैग्नेटिक फील्ड की डायरेक्शन, फील्ड लाइंस को आप नॉर्थ से साउथ की तरफ मैग्नेटिक फील्ड लाइंस चलती हैं, तो आप इसको ऐसे दिखा सकते हैं. डायरेक्शन को आप ऐसे भी दिखा सकते हैं. अगर ये करंट की डायरेक्शन ऐसे जा रही है, अगर करंट की डायरेक्शन में अगर आप ये फिंगर्स को टर्न करें तो दी थंब विल शो द डायरेक्शन ऑफ मैग्नेटिक फील्ड. तो ये नॉर्थ पोल आपके थंब की डायरेक्शन में, दिस विल बी द डायरेक्शन ऑफ थंब. सो नॉर्थ विल बी along this direction. Direction of magnetic field can also be understood by right hand thumb rule. जैसे एक लूप आप ले लीजिए, लास्ट वाला ही लूप लीजिए. यहाँ से मैग्नेटिक फील्ड कैसे जा रहा है, करंट अगर आप इस तरफ से लें तो एंटी क्लॉकवाइज है और इस तरफ से लें तो क्लॉकवाइज है. तो मैग्नेटिक फील्ड लाइन से ऐसे जा रही है तो टेंजेंट ड्रॉन बाहर को देगा आपको मैग्नेटिक फील्ड. ठीक है, मैग्नेटिक फील्ड विल बी आउटवर्ड्स और इस तरफ को आएगा. ये नॉर्थ पोल होगा. Let us understand the definition of solenoid. Once again, what is solenoid? Solenoid is a cylindrical shaped device or cylindrical shaped structure. It is made up of closely wound insulated turns of conducting wire. These are closely wound and a number of turns are there of conducting wire and these are insulated ones. These all are not in electrical contact with each other. Each turn is isolated electrically from other turn. Current is passing through wire only and its length is much larger than its diameter. What is the length of ideal solenoid? That is infinite, but it is not possible. Infinite length is not possible. So ideal solenoid is that solenoid whose length is much larger than its diameter. We can find magnetic field by making use of Ampere's circuital law also. You have seen this is a solenoid and this solenoid can be represented like this also. What is this structure? Let us take one such turn of this solenoid which consists of several such turns. The direction of flow of current through this turn is clockwise. From left end of this turn the current is coming up. So the direction of current is shown by dots in this diagram and through right end of this turn current is entering. As it is clockwise, so it is going down. So this direction of current is shown by crosses along the length of this solenoid. So as per Ampere's circuital law, line integral of magnetic field around a closed loop in free space is equal to mu naught times the total current threading the area bound by the closed loop. B dot dl, it's a line integral along closed loop, is equal to mu naught times I. This is Ampere's circuital law. How will we use this Ampere's circuital law in case of solenoid to find the magnetic field inside it? So we will take a point P well inside the solenoid. Including this point P, we will consider an Amperian loop, that is C, D, E, F. Suppose CD length is equal to L. The length of the CD part of this Amperian loop is L. So we can divide this line integral into 4 parts along length CD along length DE, along length EF, and along length FC. So this line integral of magnetic field V dot dl about that closed path is equal to how much? Integration of magnetic field about CD plus integration of magnetic field about DE about the path B dot dl about the path EF plus integration B dot dl about path FC is equal to how much? Mu naught I. We have taken L length of this solenoid. In L length, how many turns will be there? Suppose small n be the number density. What is number density? Number of turns per unit length of the solenoid. What is n? Number of turns per unit length of this solenoid. So in L length, how many turns will be there? Unit length n turns are there, then in L length n into L turns will be there. Through one turn, how much current is flowing? I current is flowing. So through NL turns, how much current will flow? NL into I. Now this mu naught, as this solenoid is placed in free space, so mu naught will also come here. So RHS will be mu naught NLI. What about this LHS? Let us solve the left hand side of this equation. इस पार्ट पर ध्यान देते हैं. लाइन इंटीग्रल ऑफ मैग्नेटिक फील्ड अराउंड ए क्लोज्ड लूप. इसको हमने 4 पार्ट्स में डिवाइड कर दिया है. दिस इज अबाउट CD, DE, EF and FC. CD part. For CD part, what is angle between DL and magnetic field? That is 0 degree. DL means a line element and magnetic field both are directed along the same direction, so angle between them will be 0 degree. तो इसको एक्सपेंड करेंगे तो क्या मिलेगा आपको? This is BDL cos 0 degree about CD plus about DE, angle between line element and magnetic field is 90 degree. Line element we will take along this axis and magnetic field is along the axis of this solenoid. तो DL और B के बीच का एंगल 90 डिग्री है. So this will be BDL cos 90 degree plus about EF. In case of EF, magnetic field will be 0 as the linear element is lying outside the solenoid, and outside the solenoid magnetic field is negligible, as we have already seen in the case of solenoid. Magnetic field is always there inside the solenoid and that is uniform and strong. That is the characteristic of solenoid. So we can put it as 0. We can replace B dot dl along EF by 0 plus about FC. This is again FC is at right angle to magnetic field. This will again be B dl cos 90 degree is equal to mu naught NL into I. So first term is equal to BDL cos 0 is 1 about CD. Second term will vanish as cos 90 is 0. Third term is 0. Fourth term will also vanish because cos 90 is there, is equal to, in right hand side we will get mu naught NLI. Mu naught NLI. So line integral of magnetic field around the closed loop is equal to, B can be taken out as it is constant, and integration of DL about CD. The CD length of this Amperian loop is equal to L. So we can write it as equal to B into L. Now this B into L is equal to mu naught N I L. Mu naught N I L. This L will cancel. this L. Therefore, B is equal to mu naught Ni is the expression for magnetic field inside the solenoid. If magnetic material of permeability mu is there, suppose ferromagnetic material or iron piece is taken, in that case permeability mu naught will be replaced by permeability of that medium. Suppose it be mu. In that case, this expression will be modified as B is equal to mu Ni. B is equal to mu Ni, where mu is permeability of that medium which is inserted inside this solenoid to increase its magnetism. Because ferromagnetic material is highly susceptible to magnetic field lines, so maximum field lines pass through ferromagnetic material, so its magnetic field increases. That's why we can use magnetic material like iron core also. In that case permeability will be mu. Suppose total number of turns in this solenoid be n. Suppose n be the total number of turns in this solenoid. Then what will be n? N is equal to small n into length of this solenoid. Suppose L is the length of solenoid. So in that case, small n will be equal to capital N by L. So this expression can also be replaced as B is equal to mu times n will be replaced by capital N by L into I. This is another way of expressing the same expression. N is capital N by L, number of turns per unit length of this solenoid. This is all about this topic. Thank you.